In this video, we're looking at standard form, which is just a special way of writing numbers, particularly those that are really big or really small. The key point to remember is that we always have to write standard form in this general format, where a, which we can call the front number, is a number bigger than or equal to 1 but less than 10, while n, which we call the power or the index, can be any positive or negative whole number. To see what I mean, let's take a look at these four numbers and see if each of them are in standard form or not. The first one, 4.5 times 10 to the power of 4, is correct standard form because the front number, 4.5, is between 1 and 10, and the power or index of 4 is a whole number. This second one, 0.7 times 10 to the power of minus 2, though, isn't in standard form because 0.7, which is the front number, is less than 1. 9.34 times 10 to the power of 5.5 also isn't correct standard form. The front number of 9.34 is fine because it's between 1 and 10, but the power isn't a whole number, so it doesn't count as standard form. The last number, 1 times 10 to the power of minus 13, is absolutely fine. The front number is okay because it's allowed to be 1 itself, and the index is fine because negative 13 is a whole number. Now, the way that standard form works is that if the power is positive, then it tells us how many times we need to multiply the front number by 10. For example, 2.7 times 10 to the power of positive 3 means 2.7 multiplied by 10 3 times, so we can see that its actual value is 2,700. Meanwhile, if the index is negative, it tells us how many times we have to divide our front number by 10. So, 5 times 10 to the power of negative 2 is just 5 divided by 10 twice, so 0.05. If you think about it, this means that anything with a positive index is going to be a relatively big number, whereas anything with a negative index is going to be a fairly small number. Now, another way that you can think about these powers is that they tell us the number of places that we need to move the decimal point. If the power is positive, then you move the decimal point to the right, making the front number bigger, but if the power is negative, then you move the decimal point to the left, making the front number smaller. So, for 2.7 times 10 to the power of positive 3, the positive 3 tells you that you're going to have to move the decimal point 3 places to the right. To do this, we write out the 2.7 and then, using little arrows, move the decimal point 3 places to the right, so 1, 2, 3, which means that our new decimal point would be here. Then, you just fill in all the empty spaces with zeros and remove the old decimal point, so we end up with 2,700. Because there aren't any decimal places, we actually don't need the decimal point anymore. 5 times 10 to the power of negative 2, the negative 2 part means that you need to move the decimal point 2 places to the left this time. So you write out the 5 but also need to add a 0.0 so that you can work with the decimal point. Next, you can add your arrows going 2 places to the left, so 1 and 2, and then add the new decimal point and the zeros into the gaps. To finish, we can just remove the old decimal point, and if we want, we can also get rid of this 0 that we don't really need anymore, leaving us with 0.05 as our answer. Anyway, that's everything for this video, so I hope it all made sense, and we'll see you again soon.